Cast is now starting. All attendees are in listen-only mode.
Good morning and welcome to today's webinar. Today's webinar provides an overview of Oracle Database Advanced Analytics, and it is hosted by Brian Kelsey, Principal Consultant, and Dhruv Sethi, Technical Consultant at Edgewater Ransell. Brian?
Thank you, Joey. Hello, everyone. As Joey mentioned, I am Brian Kelsey, a Principal Consultant with Edgewater Ransell, and today I'm presenting with my colleague Dhruv Sethi to demonstrate the latest advanced analytics capabilities of Oracle's cloud database versions 12c and 18c. If you are unfamiliar with Edgewater Ransell, we are a professional services company that specializes in strategic design, implementation, and support of Oracle's EPM suite, as well as several analytics technologies in business intelligence, big data, and advanced analytics. We also offer managed services, customized training, and support services as well. We are an Oracle Platinum partner, so of course we cover business intelligence cloud service for your dashboard, scorecard, financial, and operational reporting needs, but also specialize in cutting-edge business intelligence and dashboarding tools from Incorda and Microsoft. Outside of implementation, we offer services including cloud migrations, data integration, financial data management, ETL services, master data management, and warehousing. From a big data and advanced analytics perspective, we cover Oracle's Analytics Cloud Platform, which includes the previously mentioned BI Cloud Service, Essbase, and Data Visualizer, which we have covered in previous webinars available on our website, ransell.com, as well as Big Data Cloud Service and EBS Information Discovery, which is based on the Endeca technology. Outside of Oracle, we also cover open source technologies in the Hadoop space, including Cloudera, Hortonworks, and the Elastic Stack, providing services extending our services to include cloud migrations, ETL offload, integrated analytics planning, and discovery solution integration, as well as cluster certifications, cloud hosting, POC, and accelerator programs to help prove out these new technologies. Today, we will be covering the latest versions of Oracle's cloud database that actually spans both data management and analytics into a single platform that most of our customers may already be using presently. On the agenda for today, we will explain the process of data mining being utilized to solve some of the most interesting business cases to date, as well as some of the platform challenges in implementing such a solution. We will also cover Oracle's latest offerings and their advanced analytics architecture. We'll take a brief look at the evolution of Oracle's database technology and the integrated tools available. Then, finishing with a demo of the machine learning workflows from within Oracle's cloud services. Data mining is the process of extracting useful information from masses of data by extracting patterns and trends from that data. Data mining is being used to solve many business problems today, including predicting individual behaviors, finding profiles of targeted populations, finding natural segments or clusters, as well as finding co-occurring events or purchases. In order to implement data mining to solve these problems, there are several phases to consider for any upcoming project. First, you will need to define the problem in terms of data mining and business goals. Once that is determined, next is the largest and longest portion of the process, taking more than 50% of project time in most cases. The business needs to focus on data acquisition and preparation, which includes wrangling perhaps several source systems, integration of that data, and filtering it to define a proper training data set, as well as how much data is necessary for highly confident results. After that, next is creating, testing, and evaluating the models to train. Once you have gone through the process and have selected the appropriate model, you'll need to interpret the results and apply it to an extended data set, and then finish with actual deployment into the enterprise where you will continue to create customer reports and dashboards, as well as build this process into existing production data processes. Already, this is sounding like a lot of moving pieces, processes, and perhaps several platforms to orchestrate. Yeah, so challenges with the platforms involved that provide the foundation for successful execution. First, being the amount of duplicated data across platforms. So when we talk of databases, data warehouses, data lakes, maybe an RStudio instance, and analytics tools providing the functions necessary to complete advanced analytics, there needs to be duplication and movement of data across these platforms, especially if you have already integrated into a hybrid on-premise and cloud implementation. All of this results in no single source of truth for reporting needs, security challenges with transfer and storage of data, and backup challenges, including what, when, where, and how to back up this data, not without mentioning the increased space and power requirements to support this sprawled architecture. Oracle's solution to these challenges are its suite of platforms within its Oracle Advanced Analytics architecture. Let's take a closer look. Oracle now provides, within its Oracle Cloud Services, 3 advanced analytics solutions based on your organization's data footprint and business cases, all accessible through their familiar Big Data SQL. They offer Big Data Cloud Service for a Hadoop-based implementation, offering machine learning algorithms executed in a distributed, scalable environment. They also offer Autonomous Data Warehouse for large warehouse implementations that offer the machine learning execution from right within the database. And lastly, what we will be covering today, Oracle's database, which also offers all-in-one storage, transformation, and in-database execution of these models. The 2 distinct audiences for these platforms are firstly, the information producers. These are the individuals that are using RStudio Client, perhaps SQL Developer, and Data Miner to interact with the data and create, train, and apply ML models and workflows. The second distinct audience, or the second distinct part of this audience, is the information consumers, those looking to take the output of these workflows and deliver reporting and dashboards to a wider audience for additional analysis within the likes of, say, Oracle's Data Visualizer, Power BI, Tableau, or predictive applications like Oracle's HCM. Any tool that can interact with an Oracle database can take these machine learning outputs and use them for additional analysis. There are also several other benefits we will talk about. But as you can see, with this architecture, the data always remains in the system that it is stored, and the users merely interact with the source platform with no need to transfer and move the data back and forth. Now let's talk about a couple of those other benefits. As I mentioned, the data remains in the database or in Hadoop for Big Data Cloud Service, eliminating the need for data extraction and data import to make our workflow more compact. The model building and scoring occur in the database with the additional advantage of being able to run parallel processes and remain scalable to business needs. For some of you, you may be able to leverage the investment in Oracle IT that you have already made. Many customers are already using an Oracle Cloud database and are not aware that these capabilities are locked inside, ready to use. Additionally, all of the creation and application of the machine learning models is completed in easy-to-read GUI for workflow and code generation, and Dhruv will be demonstrating this shortly. Moving to the latest Oracle Advanced Analytics architecture eliminates the data duplication, the need for separate analytical servers, and extends a new or existing data management platform. Let's take a quick look on how Oracle's database progressed to its present state to provide these benefits. To provide some additional background, you can see on this slide that Oracle has been acquiring knowledge, developing, and embedding machine learning technology into Oracle databases since 1998 in version 8i. As they have progressed over the years, they have reached a point where they now have embedded over 30 algorithms into their advanced analytics platform, as well as made the process more user-friendly through Data Miner version 4's GUI, which you will see in a moment. And now, a large portion of the day-to-day database management activities is autonomous, allowing IT to focus more on supporting the enterprise and less on supporting the database. So for reference, here's a quick look at the machine learning algorithms now embedded into these OAA platforms. everything from classification, including neural networks and decision trees, to clustering, anomaly detection, time series, and regression. You will find everything you need to progress from data management into advanced analytics with Oracle's latest versions of database. For today's demo, Dhruv will be demonstrating Oracle's data miner and how an end user can take this machine learning model building methodology, which is starting with historical data, perhaps transactional data, as well as any other relevant data, assembling those into a data set that's ready for consumption, building and training a model on that assembled data, and then next, taking an assembled current and historic data set to execute the model on to make predictions in an output of a new data set, ready for analysis in a dashboarding, reporting, or visualization tool. And now just imagine taking this complete workflow that is all being done within a single database where the data already resides and can be executed as soon as the data comes in and reported or visualized in any reporting or analytics tool you may already be using. The tools that Dhruv will be using today come free from Oracle for integration within your Oracle Cloud database. First is SQL Developer, which is a free integrated development environment that simplifies the development and management of Oracle database in both traditional and cloud deployment. Many of you may already be using this tool to manage your data, creating worksheets to build SQL scripts and modeling your data. The new extension being offered from Oracle to SQL Developer is Oracle's Data Miner, which enables data analysts to view their data, build and evaluate multiple machine learning models, and accelerate model deployment. So now I will hand it over to Dhruv to demonstrate all of this amazing advanced analytics capability and capacity for you. Dhruv?
Brian, you can see my screen?
Yes, I can see your screen.
All right. Thanks, Brian. In this demo, we show you how to unlock advanced analytics, machine learning capabilities in the data miner, and how to turn your current data management platform into an advanced analytics platform. To run advanced analytics or machine learning algorithms on the data sets, we first create a project, and then we create a workflow within a project. For this demo purposes, as you can see, we've already built out a workflow to show. What does the workflow window contain? The workflow window serves as a canvas on which we build graphical representation of data mining process flow. Each element in the process is represented by a graphical icon called a node. Each node here has a specific purpose, contains specific instructions, and may be modified in numerous ways. These nodes can be added by simply dragging them onto the workflow area. The lower component of the page shows us the Properties tab, which gives us properties of each node that we select. The upper right-hand side of the interface consists of Components tab, from where we drag-drop nodes onto the canvas. To build this workflow, we identified and examined the source data, built and compared several classification models, selected and ran models that produce actionable results. In this particular workflow, we are going to try and predict the customers who are more likely to buy insurance. The first node in this workflow is the data source node, which was dragged from the data tab in the workflow editor right here. We have selected insurance customer sample data from the available data set. The list of columns and the data associated with and the data type associated with the columns can be seen below in the Properties tab. To view the data, right-click and select View Data. This shows us data in the grid form. You can also see SQL statement as well as the list of columns along with the data types associated with the data. The next step for most line of business people to do is to explore the data. Oracle Data Miner has an Explore Data node in the Data tab that we dragged onto the canvas. As you can see, we've already connected the data source node with the Explore Data node by right-clicking and selecting Connect. When you click the Explore Data node, you can see that the property inspector at the bottom consists of input, which gives us list of columns given as input. It shows us the statistics that we are running on the data set. Also gives us the output columns on which it ran the statistics. Moving on from here to the sample, this allows us to select all the data or just the sample data. In this case, we are using just the sample data, although if a business user wants, they can use all the data for graphing. Let's now look at input and statistics of the Explore node in detail by clicking the node. For this case, we have grouped the data by insurance. The Statistics tab allows us to select the statistics we want to run on the data. For instance, for this case, we've selected mean, median, average, minimum, maximum, histogram, and so on. We then run the node. This saves the workflow in an XML type object that's stored in the schema, then schedules the job to run that the data miner has asked the database to do. So all the statistics and the math is done inside the database. Let's right-click and view the data. Here you can look at the data as well as the statistics. Let's take a look at the statistics right here. Here we see that for each of these variables, it's created a nice little summary. Let's take a look at age. Here we have grouped different age groups by insurance. This shows us what number of people in what age group buy insurance. We can similarly take a look at other attributes like car ownership, credit balance, credit card limits to try and find pattern for buying insurance. Along with looking at different variables, we can also look at other statistics like median, mean, minimum, maximum, standard deviation, and so on. The data is also viewable in a grid form, so we can sort of drop it on another template and spit it out and start taking a deeper look at the numbers. Or we can use any other visual tool in the market, like a data visualizer, to visualize the data, or even use a graph node that's available in the database to visualize this data. Let's now try and visualize some of the attributes within the database using the graph node. The graph node was dragged from the data tab as well. As you can see, I've already connected the data source node with the graph node. In a similar way, I connected the data source node with the Explore node. Double-clicking the graph node takes us to a new graph display window. Here you can see we have two visuals in the form of histogram and box plot. The first one gives us age grouped by LTV, and the second one gives us box plot of LTV grouped by marital status. We can add similar visuals by clicking the plus icon and then selecting the type of chart, assigning a name to the visual, then selecting attributes in the histogram settings, and then enabling a group by option and selecting the attribute with which we want to group by. Let's move on from a high-level manual analytical exercise to using the power of database. The business problem that we're trying to solve is predicting customers who are going to buy insurance. In this case, we ran a classification model to predict customers likely to buy insurance. As the name suggests, it basically runs 4 models for you with same target attribute and case ID, and allows you to compare the results of these models, with which it helps you determine which algorithm gives the best prediction. Let's look at the Properties tab and investigate the model further. In this case, we've selected our target attribute as buy insurance and case ID, which is your unique identifier, as customer ID. Once we selected our target variable and case ID, it runs the 4 models mentioned on the screen for you. Till now, we are trying to build selected models against the source data. This operation is called as training, and the model is set to learn from the training data. One of the common data mining practices is to build your model against part of the source data and then test the model against the remaining portion of the data. We can now look at the test section of the properties tab. As you can see, we can specify whether to perform a test or not, which type of test results to generate, and what percentage of data should be used for testing. In this case, 40%. We then run the node for this demo. We've built out we've already ran the node. We can now right-click and compare the test results we built against each other, and then begin applying the model that provides the best prediction. Comparing the models can be done by using different techniques. For instance, we can consider performance of the model, which determines how accurate they are. From the numbers below, it's clear that the decision tree has the highest average accuracy with almost 80%. Then we can take a look at performance matrix, which provides how accurate each model is for predicting yeses and nos. Again, the decision tree gives us the highest correction prediction with 81% of accurate prediction. We can take a deeper look at it and see that it provides 78% of accurate prediction for predicting the yes values and 81% of accurate prediction for predicting the no values. Then we can take a look at lift, which shows incremental comparative advantage of using different models depending upon how deep I go into the data population. For instance, moving the x-axis to 40th quantile shows a significant difference in gain cumulative percentage number. And notice that the decision tree again stands out with slightly over 82% of gain cumulative percent. Now, with all these numbers, it's evident that decision tree works best for this particular use case. Once we decide which model we want to apply on the data set, we can then turn off the results of the other models. As you can see here, the red color X in the output column below indicate that the output of these models are turned off. Now, we then added a new data source in the workflow. Even though we are working with the same table as the apply data source, we must still add a second data source node to the workflow. We've selected the same table, although given it a different name. We then dragged an apply node from the model tab. We then connected the classification build node to the apply node, and then connected the data source node to the apply node. The apply node by default creates 3 columns of information for each customer. The prediction, which gives values yes or no, the probability of prediction, and the prediction cost. We also want to know how the information for each customer correlate with other attributes in the data set. We can then add other attributes by clicking the additional output tab and clicking the plus sign. You can select all the attributes in the available attribute list or select only a few attributes that you're interested in. For this case, we selected all the available attributes. Once you are ready to apply the model, you can then right-click and select Run the Model, which will then apply the model on the data set. For this case, as we have already applied the model, let's take a look at the result. Once the model completes its runs and generates the result for you, we can then create a table by dragging it from the Data tab. For this demo purposes, we've already created a table. Let's take a look at the result. Now, this data can easily be imported in any visual tool like a data visualizer for actionable insights. So in this demo, we saw how to run a classification machine learning model on the data set, but the functionality of the data set is not just limited to that. In the component tab, we have transform tab, within the workflow editor, which consists of JSON query, which converts unstructured data into structured data, which can then be used to run advanced analytics machine learning algorithms on it. We can also integrate R and run custom R scripts on the data sets. The text component tab allows us to work with text data and apply advanced analytics on it. We also have other machine learning algorithms like anomaly detection, association, and clustering. Also in this demo, you saw how to build and apply a model in 5 steps. But the function of predictive queries allows us to select the model as well as apply the model on the data set in just 1 step. If you want us to help you in unlocking these advanced analytics machine learning capabilities and get more out of your data in the database, please reach out to us at info@ranzal.com or information mentioned in the slide. From here on, I'll pass it on to Joey to conclude the webinar.
Thank you, Dhruv. Thank you, both Dhruv and Brian. Again, as Dhruv just mentioned, email any questions to info@ranzal.com and we will provide a response. A recording of this webinar will be available on our website shortly, where you may also find previous webinars posted. We hope you gained insight from today's webinar. Please visit our website to learn about and register for upcoming webinars, and follow us on social media to get alerts about upcoming events, training, and webinars. Our upcoming webinar on August 16th provides insight into how the adoption of Oracle Tax Reporting Cloud Service can help users to build an effective, efficient, and transparent corporate tax function to better navigate the complexities of tax. And it highlights specific features and functions of this enterprise technology to demonstrate the value of using a completely integrated, comprehensive tax data and process improvement platform. You can register for this and other upcoming webinars by visiting our website. Thank you again to our audience for joining us, and to both Brian and Dhruv for sharing your knowledge and expertise during this presentation. This concludes today's webinar.